Jacobean explained. What is Jacobean? We have been using Jacobean transformation from A-level mathematics as we know it. We have ways to solve integration, that is by recognition, integration by parts and integration by substitution. We have done them. Okay, let's look further about integration by substitution. Okay, let's look at example in our next slide. From the above integral with bounds at x equals 1 to x equals 5 write. If we use the substitution say u equals 2x minus 5. The integral becomes as follows. Notice the dx is integration in terms of x only, so we need dx by du, so how do we do it? Let's look in our next slide. How? Since we let x equals 2x minus 5. That's where we will find du, by differentiating du in terms of dx. Then we make dx the subject of the formula. Then we go back to our original equation and substitute dx with the value you got. And after you substitute dx, now your bounds are no longer the same, they are transformed, your new limits comes from the equation for substitution. Let's look at how we do it. We let u equals 2x5. And we get as follows. Now we differentiate our substitute u equals 2x minus 5 in terms of x. Then make dx the subject of the formula like as follows. Now we replace dx with our equation, and now it becomes as follows. Now remember, now our bounda are no longer 5 and 1, they have been transformed to new values, and our Jacobean is as follows. That is our transformation. Now how do we solve for p and q our bounds? Let's see in the next slide. To find p and q we use our equation u equals 2x minus 5. Remember p and q are no longer values for x, but for u, so when x was 1 then our u becomes negative 3, and when x was 5 then our bounds for u upper becomes 7, so our bounds are now from negative 3 to 7, we say it has been transformed. So it becomes So we are now integrating quickly. If we integrate it becomes. And if we evaluate it becomes. And the final answer we got, that's our value. Multivariable. We have done single variable integral substitution, now what about multivariable variables? The concept is same, make a substitution by letting equal to something if it has two variables, make a substitution with two variables. Differentiate your substitutes. Replace the differential term with your differential result. Change the limit, find bounds using your substitution equation. And solve. Let's look at the video. First we shall use our substitution.
I'm a little kid beat.
Secondly is to differentiate our substitutes. Since this are two variables, we shall partially differentiate that fx in first column and an fy in second column, and second row is for the second substitute since there are two. And now we evaluate. Remember the Jacobean for the this polar coordinates are always rd theta, so no need to go this step. After that we work for our bounds, and since our radius is 5, we have 0 to 5 as our r, and we need a full revelation area, so our angle theta is from 0 to 2 pi.
I'm a lit kid beat.
First we integrate the first in terms of theta, keeping r as a constant. Now put the limits. Evaluate. Now integrate in terms of r. Evaluate. And we got 25 pi. Let's compare if this is correct, since we know the radius of the circle, which is 5. Its area it's pi r squared, which is pi times 5 square, which is 25 pi, and which proves it's true.